So I'd like to spend a little bit of time talking about question number 6 on the implicit differentiation assignment. So it really, the issue that a lot of students have had with this question has really been about the distributive property. It's not about the calculus. So let's take a look at the distributive property. If we have 3 times the quantity x squared plus 9, we multiply the 3 by the x squared, and we multiply the 3 by the 9. So we have 3x squared. Basically, this becomes plus 27 back here. So that's part of the general idea. If we have rectangle times the quantity circle plus triangle, we take the rectangle times what the circle is, and we take the rectangle times the triangle. So really, that's the distributive property right there. Now, that's going to come up as we look at question number 6 of the implicit differentiation, as we said here. So let's look at this. Basically, we want to find the dy dx. We want to find the derivative, and what we have is stuff squared here. So the derivative of stuff squared is we have the derivative of stuff cubed. And the derivative of stuff cubed is 3 times stuff squared times the derivative of stuff. And we're going to take the derivative of the right side as well. So that's fine. We'll have 3 times stuff squared here. The derivative of this becomes 2x, and the derivative of y with respect to x is dy dx on both sides here and here. Okay, so we're to this point right here, and this is where the idea that we talked about here comes into play. So we have something in a rectangle multiplied. You can imagine that this is in a circle and this is in a triangle. So we're going to take the rectangle times the circle plus the rectangle times the triangle. So in this case, we're going to take that 3 times the 2x, that'll be the 6x, times the quantity x squared plus y, the quantity squared. And then we're going to take the rectangle times what I had in the triangle, which is dy dx. So it'll be 3 times dy dx times x squared plus y, the quantity squared. The right side hasn't changed at all here. Now, the goal is to get all the dy dx's on the same side. So to get rid of this plus 3 times dy dx times x squared plus y, the quantity squared, we're going to subtract 3 times dy dx times the quantity x squared plus y, the quantity squared. And that gets us what you see here. The goal in doing that was so that we could have a dy dx on both sides. We can factor that dy dx out, divide both sides by this quantity that we have here inside the parentheses, and then we will have our answer to number 6. So as I said, I think the real issue is just making sure that we understand that when we take something times a sum, we multiply that times both terms inside the sum. Our something in this case, our box, is 3 times the quantity x squared plus y, the quantity squared. Our circle was the 2x, and our triangle was dy dx. I hope that helps with question number 6 on the implicit differentiation problem here, or assignment. Thanks.